Hi everyone, welcome to this episode of Cytobytes, where I will talk about one of the questions I get asked the most often. How do I decide on the number of clusters in a FlowSOM analysis? And because the FlowSOM is actually a two-step clustering procedure, this means people have two questions. It's how to decide on the grid size of the FlowSOM algorithm, as well as how to decide on the number of meta-clusters in the FlowSOM analysis. I'll try to share some insights on both of these topics today. When we're talking about grid size, the most important thing is that the grid size is large enough that the smallest population of interest will get picked up. It's very hard to put this into actual numbers. It doesn't translate one-on-one like, oh, you want this percentage of cells to be picked up, so you need this number of clusters, because also how much they vary from the rest of the cells in your sample plays a very big role in that. However, as a guideline, it's always good to try to overcluster. At this point, we're not trying to have one cluster per biologically meaningful population, but rather just to have as many clusters to make sure that each of them are still pure. With a self-organizing map algorithm, it makes the most sense to use a square grid, but a rectangular grid is also possible. So if you're saying like, oh, I want exactly 50 clusters in my grid, it's not possible with a square one. Go for a rectangular one. It won't impact your results that much. The default starting point by FlowSOM is a 10 by 10 grid, so that means 100 clusters. And I think that's reasonable if you're working what nowadays we would call a rather small panel, 8 color, 12 color, these kind of things. If you're working with larger panels, typically you also expect more unique combinations of markers to occur. So if you're working with a 20 color, 30 color, 50 color panel, I would also recommend scaling up your grid. And I typically immediately go to a 15 by 15 grid. I have some colleagues who really prefer the 20 by 20 grid, just to make sure you capture enough of this high dimensional space. On the other hand, you can also say, okay, my main goal of this FlowSOM clustering is to make a nice visualization where I have a number of clearly defined biological populations present. Maybe if the main goal is visualization, a 7 by 7 grid, meaning you have 49, so this approximately 50 clusters I was talking about before. If this is enough, it will add visual clarity to your figures. Because you only have half the number of circles in your tree, for example, it's much easier to create a clear overview. So while I think the default of 10 by 10 is in many cases still a very good point, we nowadays with the larger and larger panels typically also mean we go to larger grid sizes, and in a few specific cases it also makes sense to go smaller. Once the clusters are there and the self-organizing map is learned, we still need to get to clusters that are actually of biological interest. And to do that, we use this meta-clustering step in FlowSOM. And there, the main idea is that you want to have a bit more than what you would actually expect to be there. Because there will always be some unexpected things that are also getting separated off. And it's much easier to merge some things together than to still have to split things after the clustering procedure. So even though it's in a way less extreme way than the original one, I would still suggest over-clustering here. Either you have some intuition about the number of populations you expect because you built your panel, you know which markers are in there, you know approximately the number of populations you're expecting, or maybe you did some first exploratory dimensionality reduction to visualize your data, and you have some notion of the amount of islands that are getting separated in a t-SNE. Overall, if we look at actual numbers, I would even go up to 1.5 times the number of populations you're actually expecting. So if you're expecting 10 populations, you would gate manually, maybe go for 15 meta clusters. If you're expecting 20, maybe go for 30 metaclusters and so on. Once you have a result, then of course you will still need to inspect these, and either you can have a look at the pies, you can visualize all kind of things of them, but what's often the most helpful is to look at actual scatter plots of your metaclusters, where you can then check of, okay, are these now sufficiently pure? Do I still see a lot of mixture of different cells in them that I think should not be clustered together? That means I need to increase my cluster number. Or do I see some populations that actually seem numerically different? So there's a slight change in value for some reason, but it's just based on spread or things like that. So it's not of biological value, and they can be merged together. In those cases, either you can decide to rerun your metaclustering and have a look at how many clusters you get, or maybe you can then make some manual alterations to your metaclustering. There are also some algorithms who try to decide these numbers based on the quality of the clustering. The ones that are present in the FlowSOM algorithm, I actually would not recommend to use. They typically strongly underestimate the number of metaclusters. So they will say you just need, I don't know, maybe 5 if you know for sure there's 10 relevant populations in there. And I'm looking forward to maybe at some point in the future having better automated estimates there. For now, rather be safe than sorry and go on a too high number of metacluster rather than accidentally underclustering. Thanks a lot for listening to me today. See you at the next episode of Cytobytes. Bye-bye.